we are going to talk about the number systems. There are mainly four types of number systems that we have to talk about. The decimal number system, okay. We have the decimal number system, okay. And then we have the binary number system. Then we have the octal number system, okay. And finally, we have the hexadecimal number system. We have hexadecimal number system. Only these are the main number systems that we are focusing when we are learning about new number system. So first of all, let's talk about the decimal number systems. Yeah. So decimal number systems means it has 10 numbers. Okay. So there are only 10 numbers that we can use in this specific number system. So what are the numbers that we normally know? 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so these are the 10 numbers that we normally use when we are using the decimal number system. Okay, so this is the important thing that you have to keep in mind because this is the main difference between all these number systems. Okay, so before I go further with other number systems, let's talk about the place value idea. Okay, let's talk about the place value idea. The place value idea is something that depends on the place of the number, okay, the place of the digit in a specific number. Okay, so how can we understand that? So let's draw an abacus. Okay, let's draw an abacus. Okay, so we normally use abacus to write numbers. Yeah, we normally use abacus to write numbers. Okay, so let's say there is a number such that we have a number that states 4,324. Okay, 4,324. So how you can represent this is, okay, so in the ones place, okay, in the ones place, which is the place value, the ones, okay, in the ones place, we have 4 bits, okay, so we have 4 bits, so that's why we have the digit 4 in the ones place, okay, and then here this one is the tens place, okay, this one is the tens place, okay, so here we have 2 bits. Similarly, okay, for 3, in this case, for this digit 3, the place value is hundreds. Okay, place value is hundreds. So we have 3 bits here. And finally, for thousands value, okay, for the thousands place value, we have 4 bits. So let me draw that also. So this is how normally a number is written in a decimal number system or in any number system that we are going to look hereafter. Okay, so these are the basic things that you have to keep in mind, the place value. So you may think, why do we put 1 here? Why do we put 10 here? Why do we put 100 here? Why can't I put 10 here and 100 here? Yeah, you may think like that. Well, there is an idea behind that also. Okay, so we can't blindly say put 1, 10, and 100 and thousands when we are learning about number system. Okay, when you started learning about this, maybe you may think like, okay, it's a convention, we can do that. But if you know the true meaning behind this, you will be able to easily tackle the other number systems. Okay, so here we have ones. The meaning is, since we are using the decimal number system, since we are using the decimal number system, where we have 10 digits, okay, instead of numbers, let me use the word digits. Okay, since we have 10 digits, okay, the place value is given such that the index or the powers of 10. Okay, so when we are starting here, we use the place value as 10 to the power 0. Then we use the value as 10 to the power 1. Then we have 10 to the power 2. Then we have 10 to the power 3. Okay, so similarly, we can also write in the right hand direction. Okay, after the decimal point. Okay, it will be 10 to the power minus 1. Then we will have 10 to the power minus 2. So if you draw the extended version of this abacus, what happens is here you will have 0.1s, okay, and here you will have 0.01s, okay. Even though we don't have to add any beats to it, okay, still we know this is just a 4,324, okay. We can extend this abacus, okay, in the right hand direction as well as the left hand direction. So this is what actually happens when we are talking about the place value of a digit in a number. Okay, place value of a digit in a number. This thing you have to keep in mind. because this will be handy in multiple places. Okay, when you are converting from decimal to binary or binary to decimal, okay, this is the idea that you are applying unknowingly. Okay, you don't know that you're applying it, but you are using that. Okay, so these are the basic important things that you have to keep in mind. Okay, so since we are using the number system, different number system, whenever you are writing a number, okay, let's say the number depicted here is 4324. Okay, the number should be given with the base value of 10. Okay, since we are using 10 digits, you will use 10 here. Okay, see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 digits, so the base value will be 10. Okay, similarly, we have binary. Binary is very useful because binary is used in every modern device that you see. Okay, any electronic or electric device that you use, mostly, I mean, they use the binary number system. Okay, normally 0 represents off and 1 represents on. Okay, so there can be only two digits. Okay, there can be only two digits. Okay, from this only we come up with the word bit. Okay, binary digit binary digit is equals to bit. That's what we that's how we come up with this word bit. Okay, so we use the bi here and the t here, and that will be bit. Okay, so what are the two digits we are using in the binary number system? Well, we are using 0 and 1. Okay, so here also we can apply the abacus, okay, or the place value. Okay, so let me just draw a simple abacus. Okay, so let's say four we have four rods. So this will be, let's say this is 2 to the power 0, and let's say this is 2 to the power 1. So this will be 2 to the power minus 1, and this will be 2 to the power minus 2. Okay, so this will be the place value represented in the decimal system. Okay, 2 to the power 1, 2 to the power 0, and 2 to the power minus 1, and 2 to the power minus 2. Okay, so if you are writing a number, okay, let's say there is a number like 10.11. Well, you can draw the beats. Okay, it will be something like this: 10 and 10.11. Okay, so this is how the place value can be determined for binary. Okay, but you can only use two digits. So here you have to keep that in mind in binary. And when you're writing the number, as I already said, you have to mention the base value. For binary, the base value will be 2. Similarly, we have octal. Okay, octal number system has 8 digits in it. Okay, from 0 to 7. 0, 1, 2, 3, 4. Okay, and then we have 5, 6, and 7. Okay, and here also the place value is determined by using the powers of 8. Okay, so let's say we have something like this. Okay, let's say we have something like this, and I will put this at 8 to the power 2, 8 to the power 1, 8 to the power 0, and 8 to the power minus 1. So if you draw 3 beats here, 2 beats here, and 5 beats here, okay, and finally 3 bits here. So the number represented here is 3, 2, 5.3 to the base 8. Okay, so try to visualize like this. Okay, try to visualize like this. Okay, and similarly for hexadecimal, it uses 16 digits. Okay, for hexadecimal, we have 16 digits. Okay, so each digit can be written down. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now you may think like, then what are the other six digits? Okay, so here we have 10 digits. What are the other six digits? Well, for this, okay, for hexadecimal, we use the English alphabet letters. Okay, the first six English alphabet letters as the hexadecimal digits. Okay, so you may get confused. Why are we using the letters in digits? But here, the letters are considered as digits for hexadecimal. Okay, so the other digits are A, B, C, D, E, and F. Okay, A, B, C, D, E, and F. Okay, so if you consider this, the A holds a value of 10, equivalent to 10 in the decimal number system. Okay, B holds a value of 11, and C holds a value of 12, D holds a value of 13, E holds a value of 14, and F f holds a value of 15. Compared to, when you're comparing the hexadecimal value to the decimal value, it's something like this. Okay, fine. Now you can also use the place value to find the values in the decimal values for the hexadecimal values. But let's just focus on place value for now. Okay, so let's say we have 4 rods. Okay, so we have 4 rods. Let me say this is 16 to the power 2, this is 16 to the power 1, this is 16 to the power 0, and this is 16 to the power minus 1. Okay, so I can have 1 bead in everything, right? Because 1 is allowed in this digit, in this number system. So it will be 111.1 to the base 16. Okay, so this is the basic introduction. Okay, this is the basic introduction that you should have when you are starting with number systems. Okay, when you're starting with number systems. Okay, keep that in mind. Okay, keep that in mind. So yeah, for now this is enough. Okay, for now this is enough. In the next video, we are going to focus on how to convert binary digits or binary numbers from a binary number to a decimal number. That's what we are going to focus on the next video.
Thanks for watching the first video in our number system series. If you found this introduction to decimal, binary, octal and hexadecimal number systems helpful, don't forget to like, share and subscribe for more tutorials. Hit the bell icon to stay updated with our latest video. Check out the full playlist to master number systems and follow us on Instagram. I'll see you in the next video. Until then, keep learning and stay curious. Bye bye.